discovery that the drawing, and again Atlanta Airport, emerges from the urge of many people to move more easily on land, so on the world map. Well, then there came is known as a human event, an unexpected encounter. The story with Atlanta Airport appeared first in a book that I published in the year 2000 called Shape and Structure from Engineering to Nature. It was the first full-length book that I wrote based on invocations of the Constructal law. And the Atlanta Airport story was in that book. And this book was noticed very well. On the basis of it, I was invited to give the plenary lecture at the 2009 ASHRAE Congress. This is a big annual meeting of the Association, the American Society of Heating, Refrigeration, and Air Conditioning Engineers. This is a huge thing because close to 20% of the fuel spent annually by any advanced country is spent for the purpose of heating, refrigeration, and air conditioning. That's basically what makes us feel as if there's good weather around us all the time. And I presented the Atlanta Airport story, the drawing. And after my relatively long speech, participants in this really huge hall lined up behind microphones on the two aisles that were separating the seats, and to ask questions. And I answered as best I could. And then there was an older person speaking with an accent that I thought came from Holland, someplace, and said, this thing that you showed, interesting, but the drawing that appeared, meaning in my slides, looks just like has the shape of the golden ratio or the divine proportion. This is an observation that's been very, very popular during the second millennium, especially during the Renaissance. The observation that people like images shaped this way. Most of the paintings that are hanging in art galleries are shaped this way. Facades of buildings are shaped this way. Obviously today the laptop screen is shaped this way, the business card, the banknotes, the flags of nations, with only two exceptions, are shaped this way, and on and on and on. And so this older colleague says, have you thought of predicting the golden ratio? And Adrian said, I don't know. And then the questions continued. I answered one after another. And right when I was actually getting tired, before stepping off the podium, I said, hey, wait, everybody come back. I figured out not only how to predict the so-called golden proportion or divine proportion, but why it happens. And I told them exactly what I'm going to tell you next. And yes, and which tells you it's a very short story. And then I had to go to my hotel, which was several blocks north. And I I became scared. Scared because now this entire Congress was going to publish this immensely important discovery, you know. So I spent the rest of my visit at that Congress writing the paper, which is this. Yeah. Now, I grew up in a family of medical people, and I know something about animal design. The paintings are preferred because people look at them, you see, and they look at them with two eyes. The eyes, unbeknownst to most of us, are jiggling all the time. Jiggling all the time. The eyeball is moving in jolts, 5 per second. 5 per second. The eye is taking snapshots 5 per second. They're called saccades. Saccade. A French word for short jolts. These that means that the eyes are scanning the field of vision. The field of vision is obviously flat because what you see is the horizon. And I'll call it this a field of 2 dimensions, H and L. And if the speed of scanning horizontally is called VL, and the other speed up and down, meaning the eyes moving up and down, VH. By the way, small footnote here. When you see a newborn, look very carefully in the eyes of the tiny baby. The eyes are showing you these saccades. They are. If you really pay attention, you see this movement in. It's real, and you don't see it as well in adults because muscle action decreases in frequency as the body becomes bigger and older. So the way to see the physics of vision is in the young. And then comes the question of what effect the shape of the image has on the ability of the 2 eyes to scan the whole area. So the time first of all, the time of scanning horizontally is obviously L over VL. The time of scanning vertically is H over VH. The total time of scanning the image is the sum of the 2. That's, okay, L over VL plus H over VH. And if the, obviously, shape is something to at the disposal of the artist, it means that it's free to vary. The effect of shape becomes apparent if you recognize that L and H are constrained by the size of the image that you're watching. So there's A equals LH, that's fixed. We've gone through this exercise several times. If you eliminate one of these variables, L or H, at the expense of the other, that's for the sake of memories, do that. Let's eliminate the H, which is A over L, and that means L over V L plus A over L VH. This is the old Roman 1 and Roman 2 intersection of asymptotes. And from that intersection, you get that L squared over A should be the same as VL over VH. Okay, which means, of course, that the aspect ratio for minimum time of scanning the whole area should be the ratio VL over VH. But this victory is just for the first half of the battle. So now the victory is this. There is a shape that is scanned the fastest. But it depends on the difference between these two scanning speeds. What is that difference? It's the same eye doing the scanning, so how could there be a difference? That's the way most people would ask. But not Adrian. I was in a hurry. I said I knew that this is it, meaning it's the Atlanta airport this time, much closer to the animal, and this ratio comes from another simple drawing. It is the drawing of the field of vision. In fact, you've seen this drawing in some of the old movies where the director wants you to imagine what the, say, World War II, what the soldier sees through his binoculars. And that drawing is this. In fact, go home and use your binoculars. You don't have binoculars? Huh. Why do you think I'm wearing this shirt from Safari, okay? You need, you got to equip yourself with the right equipment. So you see the intersection of two disks. The binoculars show you only, they don't show you anyway, through the binoculars you see just to draw something that's not part of the story, but in the movie they'll show you this. But there are two disks, or two portions to the field of vision, because there are two eyes. The center of one eye is here, the center of one eye is there. The radius of one of these, in other words, the one-eyed person would see a round image, not one that looks like a pretzel. And so here's the radius, and here's the radius, and here's the radius. And of course, in the vertical direction, you have the radius upward and downward. And, okay, so during the time interval of 1 sakad, T fixed, that time times V vertical was 2R, because the two eyes are moving upward in parallel. During the same fixed time, with a speed VL, because the eyes are moving horizontally in series, where the left eye leaves, the other one takes over. the length of sweep is 3r. And you discover by dividing these two that VH over VL is of the order of 2/3, or should be, to substitute in here as 3/2. This is back of the envelope stuff. Now, 3/2 is equal to 1.5. But according to my technique of intersecting asymptotes or treating this field of vision as a rectangle and other acts of aggressive behavior in the affronts to mathematics, it means order of magnitude. But the history of attractive images, which is of course much older, meaning the attractiveness is reported by most people who look at things, or most people who design things. Starting from the Renaissance, was associated with a solution to a problem from geometry. I will not get into that, but the solution to that was that the shape of a particular rectangle, which is the solution to the problem, is L over H, an irrational number that begins at 618, ... And this is from Euclid. This ratio, which coincides with the shapes that people like, was known as the golden ratio, or labeled the divine proportion, because the coincidence is attributable to God. In fact, everything that was right, and there was no scientific basis for it in antiquity, was attributed to God or to the gods of the era. And now you get the idea of what science does. Science does not eliminate the terminology or the history of the agreement among people that some things are more beautiful than other things. Meaning, beautiful things are attractive, ugly things are repulsive. But with science, you go one step beyond what the obviously smart people from the past were able to travel. Why is this shape attractive? Because scanning fast is useful. Grasping the meaning of a message. For example, the shape of the paragraph on your page of the textbook. The paragraph is shaped this way. If you have one or two equations on the paragraph, they're stacked this way in a well-written book, so that you would not read every symbol. You just look at it and you get the idea, and you move on. So scanning fast or understanding fast is useful. There's a long list of reasons. Useful for safety. You know it's time to get out when you see the danger approaching, and the danger comes through an image, I'll get it in a second, that is providing you with a message the fastest. So scanning fast is good for finding shelter. Oh, much better, finding shelter before others find that empty and dry cave before you found it. Food. Out there on the landscape, by the way, the history of humanity is about scrounging for food. To this day, now it's easier, but still that. And finding mate. Finding your mate before others find your mate is also very, very useful. Use your imagination. And that leads to the answer to the question of why are the two eyes aligned with the horizontal? Well, clearly they are aligned with the horizontal because that allows you to scan this image the fastest, correct? But that image is the image of the world. And now you know that the world is flat. Simple as that. He was forcing himself not to make a noise. Yeah, the world is flat. Why? And you look at the by the way, there was nothing, almost no animals to look at on the Earth's crust. I told you, on this very thin eggshell, before the appearance of the eye, the organ of vision. Locomotion is guided locomotion, and most of it is guided by vision. That was the eye appeared 565 million years ago. Is known as the Cambrian explosion because they found these fossils around Cambridge, England. Obviously, there were these people at the University of Cambridge who had some free time to look around. And from that moment, all these animals appeared, beginning with the fish, and the fish were more recent. All these things with eyes, say the octopi and so on. Insects also, never mind. And the eyes always point in the direction where their world exists. You see the flounder, the eyes are on top of the head because the flounder is on the bottom of the body of water. And now finally we get to the best known vertebrates, say mammals. The eyes are pointing forward. Yes. Because they're actually fast. The movement is forward. And what about the back? The animal is also aware of what's coming from behind because of hearing through the two ears, which are also positioned on the horizontal. Why? Because the world behind you is also flat. See that? So now go ahead and report me to the authorities. Yeah?
Do you think then that someone who loses one eye and then ends up having ocular vision would end up enjoying square paintings?
True.
Yeah.
True. And you see this at the checkout from the grocery. The eye that does the scanning has that shape. It's a single scanner. The single scanner at the grocery store, or this QR code.
Yeah.
There you go. Yeah, same. Yeah, so that's the answer to you. I don't know anybody who's one-eyed, meaning blind in one eye. But if you do ask this question, I think the preference is pretty clear. Or you can experiment on your own vision. You cover one eye. No, I'm serious. You cover every time you have a question. Immediately work on, you are the laboratory, and with one eye you lose, first of all you lose depth, perspective, and it's a different feeling, very different feeling. And the people who are handicapped in that sense are becoming much better at looking with one eye, much better. The same with the one-handed person. That person becomes extremely agile with that single arm, much better than the rest of us. Get it? Any other contributions to this third part of this lecture that consisted of 3 parts? I hope you see the connection between it and everything else. It is about you. And now you know the physics meaning of beauty. The physics meaning of beauty is that it allows it allows you to understand it faster. This goes from the direction of art into every aspect of the image. People talk about a beautiful face, a beautiful body. The other words for those impressions are such and such is well proportioned. Yeah, this is a well proportioned rectangle. And when you look at an image that's complicated, they talk about complexity up and down these days. Complexity. Something is complex because it is smaller rectangles stacked on top of bigger rectangles. So the so-called complex entity is made up of easy to grasp elements, and each element comes with its proportion, which is this one. Yeah. It's for that reason that, say, a human face that it's relatively oval, that's occupied by two huge eyes, is not good looking. The eyes by themselves should occupy something that looks like this, which has this ratio. The same with everything else. The mouth. If you, there's one of my students is a very good graphic artist, one of my advisees, and he told me how he draws a face this way. He starts with drawing the mouth, the eyes, and then everything else around it is like a less interesting superstructure, because people look first at these two parts. Yeah. All right. Come back next time. And by the way, next time this kind of story will continue.